Lecture 7. Reactions in the aqueous solutions. Objectives. Learn about some of the factors that cause reactions to occur. Learn to identify the solid that forms in a precipitation reaction. Learn to describe reactions in solutions by writing molecular, complete ionic, and net ionic equations. Learn the key characteristics of the reactions between strong acids and strong bases. Learn the general characteristics of a reaction between a metal and a nonmetal. Understand electron transfer as a driving force for a chemical reaction. Know various classification schemes for reactions. Consider additional classes of chemical reactions. Introduction. Many chemical reactions occur in aqueous solution, where substances are dissolved in water and interact as ions. Understanding why reactions occur, predicting their products, and representing them correctly is essential to chemistry, biology, environmental science, and medicine. 1. Why do reactions occur in aqueous solutions? Reactions in solution occur because the system tends to lower its potential energy. Common driving forces include main driving forces: formation of a precipitate and insoluble solid, formation of water, especially in acid-O-base reactions, formation of a gas, electron transfer, redox reactions. Key idea: if none of these occur, no reaction in R usually takes place. Example: mixing.
Sodium chloride in aqueous solution, it means that it's soluble, plus potassium nitrate in aqueous solution, what will happen? That the ions continue in solution. So as all the products remain soluble, there is no reaction.
All products remain soluble, no reaction. Solubility rules, aqueous reactions. What are solubility rules? Solubility rules allow us to predict whether an ionic compound will dissolve in water, AQ, or form a solid precipitate, S. Key idea: solubility rules are used only to decide if a precipitate forms, not reaction speed, energy, or mechanism. General solubility rules. 1. Always soluble compounds. These compounds are always aqueous. Rule 1. Alkali metal salts. Li, Na, K, Rb, CS heavy checkmark always.
Well, here you can see that the elements from group 1, the alkali metal salts, every time you observe lithium cation, sodium cation, potassium cation, rubidium cation, or cesium cation, all these compounds are soluble. Examples, here you have a group of these substances. And rule 2 expresses that ammonium salts are also always soluble. And here you have some substances that contain this cation. In other hand, the rule number 3 is for nitrates, acetates, and perchlorates are always soluble. Here you have the anion nitrate, the anion acetate, and the anion perchlorate. And here you have example of substances that contains these anions. Well, the substances that are not soluble are the chlorides, bromides, and iodides. These anions that you can see here, they are soluble only if there is not a silver cation, lead-2 cation, or this cation of mercury. So look at this. These are soluble, but when silver is a cation or lead-2 is a cation, they form a precipitate the rule number 5 is for sulfates. They are soluble except if you have a barium sulfate, lead-2 sulfate, strontium sulfate, or calcium sulfate. They are not soluble or slightly soluble. It means that there is still some solid that has precipitated. Usually insolubles are the carbonates, the phosphates, and the sulfides, except if the cation is from the group number 1 or is ammonium. But look at this with calcium and with silver, calcium carbonate and silver phosphate are not soluble. The hydroxides, the compounds that contain the OH negative disanion, is a polyatomic anion. Well, they are insoluble. Only they are slightly soluble if you have calcium, strontium, or barium. And of course, with the metals from the group 1 and ammonia, these hydroxides are soluble. Then, how to use the solubility rules step by step? Let's begin. For example, will a precipitate form in this reaction? Then what you are supposed to do? Look at me. This is a double displacement reaction. Silver will combine with chloride, and then one of the products will be silver chloride. And in the other hand, sodium will combine with a nitrate. So you will have this compound. According with the solubility rules, all the salts of sodium and all the nitrates are soluble. Then this compound will be in aqueous solution. Okay? But what happens with silver chloride? Oh, if you go to the rule, you can see that chlorides are not soluble when silver is present. Then this compound is solid. Then the net ionic reaction will be this one. Silver plus the anion chloride will produce silver chloride that is a solid. If you want to, this is the general formula, but you can do this. You can convert every ion into the solution, how they will be. And NO3 negative in aqueous solution, and also silver, sodium, and also you have the anion chloride that is also in solution. But when you go after the arrow, I'm going to continue here. Well, what's going on? That silver remains as a solid with chloride. And then sodium is soluble, then you make it ionic. And the same thing for nitrate, that is also soluble. This is the ionic equation, the general ionic equation. But what happened here that if you were in algebra, you will cancel out the equals one side and the other side. Nitrate is canceled out with nitrate because they remain in solution. And the same thing with sodium and sodium. Then what remains? The silver plus chloride make silver chloride. And this is what we call net ionic equation. Stop the video, try to do it by yourself because this is a very important task. Let's see in the following reaction. Let's see sodium chloride and potassium nitrate. Same way, sodium will go with nitrate and potassium with chloride. And the two compounds that you are going to make, sodium nitrate and potassium chloride, both are soluble. If you go to the solubility rules, you will see that both, sorry, I'm saying that they are soluble and I write an S, sorry. Then is AQ soluble and AQ. When both compounds in the products are soluble, we say that there is no reaction. But look at this. Let's go to the following example. Here we have barium chloride and sodium sulfate. Same way, barium will go with sulfate and sodium with chloride. You know that sodium chloride is soluble. But what happened with barium sulfate, according with the solubility rules, it is solid. So the net ionic reaction will have barium sulfate as a solid in the products and the cations, barium and sulfate in the reactants position. Well, let's go now. Common student traps, very important, very, very important. Listen.
Common student traps, very important. Crossmark thinking solubility depends on kinetics or temperature. Crossmark using solubility rules to predict acid-O-base reactions. Crossmark forgetting exceptions, e.g., Pb superscript 2, Ba superscript 2. Rule reminder, solubility rules are memorization plus logic, not math. 2. Precipitation reactions. A precipitation reaction occurs when two aqueous ionic solutions react to form an insoluble solid. Steps to identify a precipitate. Write the correct formulas of reactants. Predict products using double displacement. Use the solubility rules to determine if a solid forms. Example. Subindus base, ogno, final base, subindus 3, EQ.
Okay, the example is silver nitrate plus sodium chloride. Both are soluble. But when you join them together, you have to predict the products. The same way I told you, silver goes with chloride and sodium with nitrate because it's a double displacement reaction. The products produce a solid and an aqueous solution substance. So if there is a solid, you will have net ionic equation. Then first you have to write the complete reaction, predicting the products, and writing, look, if the substance is solid, you're supposed to put into parentheses a solid. If it is soluble, then you write AQ. If it is a gas, you write a G, and so on. So you now, after you predict the products, you write the full molecular equation, and after that you divide into ions. This is the ionic reaction. As it is a solid, remains as a solid, and as it is soluble, you divide into ions. After that, you have to cancel up what we call spectators, because they are the same in the product than in the reactants. Then they don't take in account, or they are not in the reaction exactly, because they remain in solution. But silver plus chloride makes the solid, and this is what we call the net ionic reaction. Remember, you have to remove the spectators. The spectators are the ions that remain the same in the reactants than in the products. Let's continue. Let's continue. When you have a strong acid and a strong base, well, always, this is what we call a neutralization reaction, because an acid and a base produce salt and water. What happened with pure water? Pure water is a weak electrolyte. So what happened? That electrolyte. Then water is a weak electrolyte, then you will have certain amount of molecules in the reaction. So the net ionic equation is water, that is a liquid, that is made of the hydroxide ion plus the hydronium ion. And this is the net ionic equation for neutralization reaction, when an acid reacts with a base to produce salt and water. Water is a weak electrolyte and remain as a molecule. It cannot be breaking into ions as, for example, the salt. Okay, let's continue then. Reactions between metals and non-metals. For example, let me go here.
A GCl is in soluble precipitate form.
Sorry, let me go into the right place. We're going to speak about reaction between metals.
Reactions between metals and nonmetals. These reactions usually involve electron transfer. General characteristics. Metal loses electrons, oxidation. Non-metal gains electrons, reduction. Products are typically ionic compounds. Example.
Subíndice base, 2 más se abre paréntesis, S se cierra.
Okay, sodium plus chlorine produces sodium chloride. In this case, sodium loses the outermost electron and makes a cation. And chlorine, that is a diatomic molecule, gains this electron that is lost here to produce two, in this case, an anion. And then this anion and this cation make sodium chloride. Okay? This is the reaction between a metal and a non-metal. In this case, we have a transfer of electrons.
Electron transfer as a driving force, redox reactions. Oxidation or reduction, redox. Oxidation, loss of electrons, reduction, gain of electrons. Mnemonic oil rate, oxidation is loss, reduction is gain.
Okay, you can use this word in order to remember that oxidation is loss. Reduction is gain. Gain what? Electrons. Lose what? Electrons. Then in this kind of reaction, someone loses electrons and the other one gains electrons. That's what we call redox equations. For example, here you have the zinc. We consider that the metals, the oxidation number of a metal in the free state is 0. And here we have copper, that is 2 plus. Oh, in the products we have zinc 2 plus and copper solid, that the oxidation number is 0. Then zinc goes from 0 to 2 plus. When the oxidation number increases, we say that this element is oxidized. Oh, but what happened with copper? Copper goes from 2 plus to copper 0. In this case, the oxidation number is reduced, and then we say that this element or substance is reduced. And the combination of an oxidation process and a reduction process is what we call redox. Remember, oil rig, oil. When we say oxidation is lose. Lose what? Electrons. That's why here zinc loses 2 electrons, while in this case copper gains 2 electrons. That's reduction. And rig means reduction is gaining what? Electrons. Okay, let's continue. Then, chemical reactions can be classified by pattern into, let's see.
By pattern. Combination decomposition, single displacement, double displacement. By process. Acid-O-base precipitation redox. by energy. Exothermic, endothermic. A reaction can belong to more than one category. 8. Additional classes of chemical reactions. Gas-forming reactions, e.g., acid plus carbonate CO2, complex ion formation combustion reactions, neutralization reactions, corrosion reactions. Thinking/tricky questions, evaluation style. Two clear solutions are mixed and a solid forms. What evidence proves that a chemical reaction occurred? Why are spectator ions included in the complete ionic equation but removed from the net ionic equation? If no precipitate, gas, water, or electron transfer occurs, should a reaction be written? Explain. Why does every strong acid, strong base reaction have the same net ionic equation? Can a reaction be both a precipitation reaction and a double displacement reaction? Explain. Key takeaways. Reactions in solution are driven by precipitate formation, water formation, gas formation, or electron transfer. Net ionic equations show what really happens. Strong acid, strong base reactions are predictable. Electron transfer explains many reactions. Chemical reactions can be classified in multiple valid ways. Tricky exam-style questions. Does a reaction occur when CaCl2, Aq, reacts with Na2CO3, Aq? Explain using solubility rules. Which ion is responsible for the precipitate in Pb, NO3, 2 plus Ki? Why is Na2S soluble but Cus insoluble? Can Ba, OH, 2 be considered soluble? Why is it treated differently from NaOH?
Okay, as you can see, you have a lot of questions here to answer. If you want, you can send me the answers, and I will tell you if you are right or no. But these kind of questions are the ones that you will have in the exam in such a way that you have to explain why, if there is reaction or if there is not reaction. Well, see you in the following video, in the following lecture.